Now, so we have seen how to find the oxidation number, right? Now we know that how to calculate the oxidation number, but sometimes in the compounds where the oxidation number is actually not stays same for an element, so the oxidation number is always written in Roman in the name. Like here it is written iron 3 chloride. It means that iron have a positive 3 charge in this compound. In the same way, here it is written copper 1 oxide, which means copper have a +1 oxidation number in this compound. Manganate 7 ion, so that 7 represent that the manganese atom in this compound have a +7 oxidation number. Okay. Is this clear? Yes. Yeah, okay, note this down quickly. Then we are going to discuss about oxidation and reduction, okay? Then, okay. So these are the 3 cases of oxidation and reduction. Till where you have written? Okay. You're done till here? Okay. So there are the 3 cases. Oxidation occurs when we observe any one out of these 3. Whether gain of oxygen is observed, if you see the gain of oxygen, if some element is gaining the oxygen, if some element is losing an electron, and in the same way, if some element is losing the hydrogen, then if any one of this case is there, any one of the cases there, then it's oxidation. And the important thing is that as a result of any one of these, this should be occur, which means that the oxidation number must be increased. If the oxidation number isn't increased and you are observing any one out of these, then you can't consider it as oxidation. Okay. So, for example, you are observing that the oxygen is lost, but when you figure out the oxidation numbers, you will see that the oxidation number stays same. Then it means it's not oxidation. Okay. Why I have put a cross over here and ticks over here? It is because this was the part of the syllabus, but now from 2023 onwards, it's excluded. But why I have written over here? Because when you do past papers and when you look in the MS, you are going to find this answer. So for the past paper things I have written over here, but when you are going to write the answer, you are going to write the answer either this way, or this way, not by this way. Assalamu alaikum. Walaikum assalam. First class. You guys come for a demo. You guys demo class. Okay. So, but we are in the middle of the chapter, so I don't know how much you are going to understand. Okay, let's see. So this thing only occurs. It is because you are not going to write this thing now onwards. Okay. In previous past papers, you are going to see this statement in the marking scheme. So that's why I've written over here. Otherwise, when you are going to write the answer, you are going to explain oxidation as a gain of oxygen, as a loss of electron, and then for the element whose oxidation number is increases. In the same way, when we talk about reduction, there are the three conditions, and you observe any one out of these three, then we assume or we consider it the process as a reduction. For example, if some substance loss oxygen from it, if there is a gain of electron by any atom or an ion, if there is a gain of hydrogen. And when any one of these occur, the oxidation number of the element is going to decrease. For example, there is a chlorine atom. When it gains electron, it becomes Cl negative. So here its oxidation number is 0, and here its oxidation number becomes -1. So from when we compare these two, I can say that the oxidation number is decreasing. So it is reduction. Now, again, why I have put a cross over here? Because when you are going to write the answer, you will not going to write this statement. You are going to write only these three statements. But in the marking scheme, you are going to observe this statement from the previous past papers. But from 2023, this is excluded. So that is for the past paper thing that you don't get why hydrogen is there. Okay. Okay, complete this. Note कर ले क्लास में आएंगे. Welcome, Khadija. How are you?
Assalamualaikum.
Why you are so late? Why you are late? Walaikum assalam. Late क्यों आए? 20 minutes. भाई ने तो कुछ चाहिए मुझे से आगे कर. In which school are you? Everything. And it's your appearing, right? You are going to appear in 2024. And your school is? Same. And you're also going to appear in 2024. Then? Glass or like
शादी नंबर बच्चे पे मिला तो बस शादी
शादी
नहीं ना शादी नंबर वही नहीं रखा
yes sir
शादी नंबर
yes everybody done आपने पिक्चर ले ली okay so there are two processes if you see one is oxidation and the other one is reduction right and these two processes are exactly opposite to each other okay so whenever there is a oxidation occurs the other substance always undergo reduction. They always occur simultaneously. It's not like that only oxidation would occur or only reduction will occur. If one occurs, then the other also occurs. Okay. So when these two occurs simultaneously, we call that reaction a redox reaction, where red comes from reduction and ox comes from oxidation. So we can say a chemical reaction where both oxidation and reduction occur simultaneously is a redox reaction. Okay, note down the definition. Then,
Yes, sir.
so now we have to talk about two substances which are involved in the redox reaction. One is called oxidizing agent and the other one is called reducing agent. For example, we have just discussed these two occur simultaneously, right? These two processes occur simultaneously. For example, if the electron is lost, a loss of electron is oxidation and gain of electron is reduction. So the common example of this kind of a reaction is, for example, there is a sodium atom and there is a chlorine atom, let's suppose. So right now they both are atom, which means their oxidation numbers are 0, which means neither they lost any electron nor they gain any electron. So we know sodium is from group 1. So what it will do? It will give away its one electron and become a positive charge. And the electron which it give away is taken by chlorine. And as a result, chlorine turns into chloride ion. So see, simultaneously both things occur. One atom loses the electron and the other atom gains the electron. So this, what sodium did? Sodium gave away its electron. So sodium just didn't give away its electron, but also it makes chlorine to gain that electron. So it means sodium is providing a help to chlorine to get reduced to gain electron, which means to get reduced. So it means we can say that sodium is reducing agent because it is reducing the other element. See, chlorine is gaining the electron and that is reduction. And chlorine is gaining the electron from whom? From sodium. So it means so chlorine is helping sodium to get oxidized. So chlorine is a reduce or oxidizing agent because it helps sodium to oxidize. It takes the electron from the sodium. And sodium gives away its electron to chlorine, which means sodium helps chlorine to get reduced. So sodium is a reducing agent. So the simple way to understand this thing, the substance which undergo oxidation is a reducing agent because it helps the other substance to get reduced. And the substance which undergo reduction is an oxidizing agent because it helps the other substance to get oxidized. Is this clear? Do you have any confusion? Yes. Okay, Manahil, did you understand? Okay. So, note it down about oxidizing agent. The common example of oxidizing agent is that mostly examiner asks is acidified potassium magnate 7. Its formula is KMnO4. Okay. So, why examiner use this? Because whenever it do the redox reaction, the color changes. Its color is itself purple, and when it behaves as a oxidizing agent, it turns colorless. So if the color change is observed when we put a KMnO4 in something, then the color change helps us to identify two things, that if the color is changes, then it means that the redox reaction took place. And the other substance with which this potassium magnate reacted is a reducing agent because this one is an oxidizing agent. Is this clear?
Sir,
Yes.
can you please explain that sodium and chlorine example again?
Yeah. Just a minute. We have did understand this in ionic bonding as well. Everybody done? Okay. Okay. For example, let me show you sodium atom. It have about 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in its outermost shell. It's a sodium atom now. And when we look at chlorine, chlorine have 2 electrons in the first shell, 8 electrons in the second shell, and as it's in group 7, it indicates that its valence shell have 7 electrons. So what will happen when these two react? When these two reacts, that sodium loses the electron from its outermost shell, and now it becomes a ion with the 2 shells only. See, initially it have a 3 shells when it was atom, and in the third shell it have a 1 electron. So it loses the electron, so it means sodium. What sodium did? If it's lost its electron, so it means it's oxidized. Is this clear? Yes, Manahil?
Yes.
Yes, Khatija? Rohil? Clear?
Yes.
Ji, aapko. Okay. So the electron that is lost by this sodium is actually gained by chlorine in its outermost shell. In its outermost shell, it have a 7 electrons, right? And the 8th one now comes, which comes from sodium. So chlorine gains electron to become chloride. So it means chlorine undergo reduction. So if chlorine undergo reduction, it gets the electron, but from whom it gets the electron? So it means it helps sodium to. So it means chlorine is a reducing agent. And sodium, when lost its electron, it lost its electron to chlorine. So it means it helps chlorine to get reduced. So that's why sodium is an oxidizing agent. No, sorry, it is a reducing agent because it helps chlorine to get reduced, right? And it itself undergo oxidation. It loses its electron, so it means it is oxidized. And that it lost its electron to chlorine, so it helps chlorine to get reduced. So sodium is a reducing agent because it is helping the other substance to get reduced. So the simpler way is that to understand or to remember this, the process that an atom itself do as an agent, it is opposite to it. For example, if itself undergo oxidation, then it is a reducing agent, and if itself undergo reduction, then it is an oxidizing agent. Is this clear? Yes,
Yes, sir.
did you understand this?
Yes.
Okay, clear? Okay. Now, reducing agent. So, it is the one which reduces the other substance and itself oxidizes. So, the common example is potassium iodide. You have to remember these color changes for potassium magnate and potassium iodide. Potassium magnate is itself a purple in color, and when it do redox, it color changes to colorless, the previous one. Here, aqueous potassium iodide is itself a colorless. So, but in the redox reaction, it turns into brown solution, which indicates a redox reaction occur, one thing, and the other thing, it is reacted with the oxidizing agent because itself a reducing agent. So let me ask you a question. We have a potassium iodide in a one test tube, and in the other test tube, we have a potassium magnate. So the test tube containing potassium iodide, what was its color? Colorless. And the test tube containing potassium magnate, its color is
Purple.
Now what I did, I poured the potassium iodide into potassium magnate. Then what color change is seen? Brown, because it decolorizes and the colorless solution turns brown. So the color change will be brown. So if the same thing is asked by the examiner and they ask you the color change, so you will write solution turns from purple to brown. Okay. It occurs very readily. You are even not, when you are doing this, you are not going to observe the colorless thing. You are seeing that purple is disappearing and at the same moment, the brown is coming. So you are not going to observe a transparent solution in between. Yes, Khatija, did you understand?
Yes.
Okay. No, you are not right.
पहला भी पूछ पहला भी मेरा नहीं लिखा था चलिए ऑपरेशन में क्या है
KI and aqueous AQ. Nahil, what is the oxidation number of an element? Mr. Rohit. If there is an element, then its oxidation number is, who is going to answer me? 0. Good. That was the first point in the rules to finding oxidation number. Done. Wait.
Yes, sir.
How many of you have a periodic table with you? Okay. You also have it? Okay. And you too? No. Yes.
Sir, I have a confusion that you tell that when you will add potassium iodide in a potassium magnet, so it will turn from purple to brown.
Yeah.
So what is actually happening between this reaction?
Okay. So basically, the thing is that potassium magnate is KMnO4, where Mn have a +7 oxidation number, and due to this, it's purple in color. Okay. And in potassium iodide, we have a iodide ion, and iodide ion is colorless in color. So when these two mixes, Mn+7 actually turns into Mn+2, and that Mn+2 is colorless. That's why in every redox reaction where potassium magnate is reacting with a reducing agent, the color changes from purple to colorless because KMnO4 turns to form Mn2 positive ion, and Mn2 positive ion is always colorless. Is this understandable? Okay. And during this reaction, the iodide turns into iodine. And as iodine forms aqueous, so when iodine forms aqueous, it's always brown. When iodine forms as a gas, it's purple fumes. And when iodine forms as a solid, it's gray-black solid. Okay, so iodine exists in 3 different colors in all of 3 states. So normally we mix the solutions, right? As I have told you, we took 2 test tubes and we mixed them. So the iodine is formed as aqueous. So that aqueous iodine is actually brown in color. So see, that's what happened. Is this understandable?
And sir, what you tell about the iodine gas?
It's purple in color.
Okay.
Iodine, when it's solid, it's gray-black. If iodine forms as aqueous, it's brown solution. And when iodine forms as a gas, you are going to observe purple fumes. Okay, is this clear? And iodine does not have a liquid state. I have mentioned aqueous, which means more in dissolved in water, because iodine always sublime. When you heat it, the solid directly turns into gas. So iodine doesn't have a molten state, doesn't have a liquid state. Okay, is this clear to all of you?
Yes, sir.
Okay. Now, we are going to observe this few examples. Okay, just note down the examples. Then I'm going to discuss these. Okay, here's periodic. Okay. So how can we figure out which reaction is redox and which is not? So the one way is by placing the oxidation number on each element and then see that during the reaction whether its oxidation number is changed or not. Okay. So the one way is this. If I look over here in the first equation, here these two are elements, right? So their oxidation number is going to be 0. And here it's a compound. So in compound, the net charge is 0, but elements do have their oxidation numbers. So if you look at chlorine, chlorine is from group 7. So if it is from group 7, so what it will do, it is going to gain an electron, right? To make complete its octet. So chlorine is going to be turned into -1 and hydrogen becomes Positive one. So now if you compare, you can see that hydrogen, the oxidation number of hydrogen is what happens to the oxidation number of hydrogen? It increases. So it means hydrogen undergo
Oxidation.
and if it undergo oxidation, then it is
Reducing it.
reducing agent. Yeah, for chlorine. So hydrogen undergo oxidation, and hydrogen as it's undergo oxidation, it is reducing agent. And from 0 to +1, we can conclude that loss of electron also occur. Because that if the charge gets positive, it means the electron is being removed from the atom. That's why the charge gets positive. So it's a reducing agent. Now, in the same way, if you compare chlorine on both sides, so the oxidation number of chlorine is decreased, right? 0 to -1. So it means it is
Reduction.
reduced. And if it is reduced, then chlorine is oxidizing.
Reducing agent.
Is this understandable? So see,
Yes.
both oxidation and reductions occur. So I can say that it's a redox reaction. Is this understandable? Okay. Now, if you look at the second equation, where calcium carbonate on heating turning into calcium oxide and carbon dioxide, does this have redox reaction or not? Yes, who is going to tell me, is this a redox reaction or not? So you will, if you will put the oxidation numbers on each element, then you can identify. So do it quickly. Put the oxidation numbers. Yes, it is redox or no? Why you are putting 0 on everyone? Why? Your tukka works, but justifies. But if you justify. Okay, so see.
Oxidation number same.
How can you say? Have you put the oxidation number of each one of them?
नहीं मतलब देख के बस.
Okay. So the net charge over here is 0, over here is 0, over here is 0. Okay. According to the rule that we have discussed, what we are going to do, we are going to first place a charge of group 1, 2, and 3. So there is a group 2 element, and if there's a group 2, then its charge would be positive 2. Then hydrogen, there is no hydrogen in it, then oxygen. So oxygen is in group 6, so its charge is going to be -2, and there are 3 oxygen, which makes it -6. So oxygen has a -6, calcium has a +2, and the net charge is 0. So what will be the charge over here, which makes when I add all of them, it becomes 0?
+4.
+4, right? +2 +4 makes it +6, and -2 times 3 is -6. So +6 -6, 0. Here, calcium is +2, oxygen is -2. Here, oxygen is -2 times 2, which makes it -4. So to get the charge of 0, carbon must be +4.
+4.
So if you compare the oxidation number of any one of the elements, for example, I am comparing calcium. it's +2 on both the sides. So it means calcium is neither oxidized nor reduced. If I look for carbon, oh, it's +4 on both the sides. It's neither reduced nor oxidized. If you look for oxygen, it also stays same, -2 before the reaction and -2 after the reaction. So there is no change in oxidation number. It means this is not redox. Is this clear?
Sir, but to see it here, there is -6, and on the other side, on the oxygen, there is -4.
No,
So
it's
isn't there a
-6 over
change?
here as well. For example, here it's you are saying -6, but -6 for how many oxygen atoms? 3. See, there is a 1 oxygen atom over here and 2 over here. So -4 here, -2 here, it stays -6.
Yes, yes, yes.
Is this clear? Okay.
Yes.
Now, okay, if you look at this equation. Yes, can you tell me whether it's a redox or not? Oh, sorry. NaOH plus HCl forming NaCl and H2O.
Redox.
Redox. Okay. Yes, any other solutions?
And redox.
Redox. Redox. Yes, Manahil.
नहीं सर redox की
सोच लें आप बताएं
एक बात
redox. Yes, Khatija.
नहीं सर redox नहीं
हाँ,
सर मैं ऑक्सीडेशन नंबर अभी लगा रही.
okay. Yes, Rohit, it's redox or not? Check करें, place करें, put the oxidation numbers, then you will find whether it's redox or not. Yes, what do you think? It's not redox. Yeah, good. It's not redox. -2 is oxygen and +1 times 2 hydrogen. So the net charge becomes 0. -1 +1 net charge 0. -1 +1 +1 -2 +1. So if you look at any element, sodium is +1 before and afterwards it's +1. Oxygen is -2 before, afterwards it's -2. Hydrogen is +1 before, afterwards it's +1. So there is no change in oxidation number, so it's not redox. Okay, so the easiest way to identify whether the reaction is redox or not by without putting these charges, how can you do that? Yes, there is a a hint to figure it out whether the reaction is redox or not by without putting the oxidation numbers. If there is an element on one side and on the other side it is the part of the compound, so for sure it's a redox reaction. You don't have to find the charges. For example, you look at this equation, these are elements, right? So it means their oxidation number is 0, but when they becomes a part of a compound, there must have oxidation number. So oxidation number is changed. You don't know what changed it, but you have an idea the oxidation number is changed because initially it's an element, so there is no oxidation number. But when it becomes compound, there must be a charge on it. So it indicates that this is for sure a redox reaction. Clear? For example, like this, we have a decomposition of calcium nitrate. When we decompose calcium nitrate, it turns into calcium oxide, nitrogen dioxide, and oxygen. Now, very simple thing. Here, oxygen is a element, right? It's not the compound. So it means its oxidation number is 0, right? And here it is a part of compound. So it means its oxidation number is for sure changed. So if the oxidation number is changed, it means it's a redox. So you don't need to work on the oxidation numbers. If you find element on one side and that element becomes the part of the compound on the other side, then that kind of a reaction is always a redox reaction. We have seen two color changes we discussed today. One of potassium magnate from purple to colorless, and the other one is potassium iodide colorless to brown. Okay, you need to remember these color changes as well for the redox, and these are normally asked by the examiner. So note it down. When copper ion is there in the aqueous state or copper sulfate, its color is blue solution. If there is a iron 2 positive ion in aqueous state, then the color is pale green. And if there is a 3 positive iron ion, then the color changes red, brown, or yellow solution. And when there is a copper solid, then it is called as pink solid. Okay, when there is a iron solid, what will be its color?
Reddish brown.
Silver. Good. See, it's a simple metal. So every metal is silver. That's it. Not iron. Ions they change their color, but when it comes to a metal, except copper, because when you see copper is a reddish brown in color. If you see the copper wires, if you peel the plastic from the wire, you didn't find it silver, right? Golden. Yeah. So we use the pink term for that. It's not the actual golden as gold is, right? So, but beside copper and gold, all the metals are silver. So whenever you are getting any metal and they have asked you what observation, you just straight write silver solid. Except these two, the copper and the gold. Otherwise, all the metals are silvery green. Is this clear? Yes. Everybody noted down this? Okay. So today we are ending the class over here, and in the next class we'll do the past papers of redox.
Sir, done.
Okay, you may leave.
Allah Hafiz.
Allah Hafiz. Allah Hafiz. Yes, sorry, did you understand? Mustafa and Mustafa. Is there any confusion?
No.
Okay.